Okay, now for what we have going back to inner product, norm, as well as distance between vectors. Now we have in the case crossing over to where we have applications of calculus, especially working with integration over closed intervals. And we have given, okay, say if we were to use the functions f and g where we have a closed interval between negative and positive 1 for x inclusive, to find the following, okay, and we have looking for the inner product of f and g, and we have by definition, we have for the inner product of f and g, that is equal to the integral of the product of f of x and g of x dx over negative 1 to 1 for the assigned values in x, okay, and for what we have with f of x and g of x, we have f of x equal to 1 and g of x equal to 4x squared minus 1. And looking at what we have for the determination of the inner product of f and g. So substituting 1 for f of x and 4x squared minus 1 for g of x. And looking at multiplying together. Okay, so we're looking at integrating over 4x squared minus 1 dx as x goes from negative to positive 1. And for the antiderivative of 4x squared minus 1, that is going to be 4/3 of x cubed minus x. And for what we have in following through, so whenever x is equal to 1 and substituting accordingly, we're going to have this statement to end up at 1/3. And for what we have at negative 1, okay, the difference is going to be at negative 1/3. And guess what? With 1 is the upper limit, negative 1 is the lower. And we're going to have for the difference between the results, we have 1/3 minus negative 1/3. And 1/3 minus negative 1/3 becomes 1/3 plus 1/3. And the inner product that we have between f and g is going to end up at 2/3. Now, looking at what we have for the norm of f, and again, that is going to be the square root of the inner product of f and itself. And again, we have for the formula, okay, for the inner product of f and g, so you have this integral statement, but for the inner product of f and itself, I'm going to replace g of x with f of x. And with f of x at 1, so I'm looking at integrating over 1 times itself over x as x goes from negative to positive 1. So I'm looking at the integral of 1 dx or just dx, and the antiderivative is going to be x as x goes from negative to positive 1. And here we're going to have 1 minus negative 1, and that's going to come out to 2. And for the norm of f, that is going to be the square root of 2. Now, looking at what we have for the norm of g, we're looking at the square root of the inner product of g with itself, and this time with the same integral, but replacing f of x with g of x. And with g of x defined as the difference of squares, 4x squared minus 1, so we're going to have g of x times itself over x as x goes from negative to positive 1. And 4x squared minus 1 times itself, we have 16x to the 4th minus 8x squared plus 1 dx as x goes from negative to positive 1. And for the antiderivatives, okay, we have 16/5 of x to the 5th minus 8/3 of x cubed plus x. And looking at what we have as x goes from negative to positive 1. So when x is 1, okay, we have 23/15 for the result in this particular trinomial, and for x equal to negative 1, we had the value of that trinomial with x at 1 to come out to negative 23/15. And so we have, in terms of the integration process, what we have with the upper limit result, and subtracting what we have with the lower limit result, we had 23/15, and what's going to be plus another 23/15. So this will be 46/15. And so for the norm of g, that is going to be the square root of 46/15. And just getting out of the radical in the denominator notation, we're going to have what is essentially going to be the square root of 690 over 15. All right. Now, for what we have in terms of the distance between f and g, so we're looking at the norm of f minus g. So for the inner product of f minus g. Okay, so we're going to determine that, and the square root is going to be the norm of f minus g, or the distance between f and g. Now, to get things situated for f minus g of x, we're looking at the difference between f of x and g of x. And again, f of x is 1, g of x we have 4x squared minus 1, and subtracting g of x from f of x, the difference is going to be 2 minus 4x squared. And for 2 minus 4x squared times itself, okay, so we're going to have 4 minus 16x squared plus 16x to the fourth dx. And taking the antiderivatives, okay, so we have 4x minus 16 thirds of x cubed plus 16 fifths of x to the fifth. Again, as x goes from negative to positive 1. And so for x equal to 1, okay, we're going to have this trinomial with the value of 28 fifteenths. At negative 1, we had the value at negative 28 fifteenths. And subtracting a negative from a positive, we have the addition of 28 fifteenths and itself. So this will be 56 fifteenths. Okay, so that will again be the inner product of f minus g with itself. So taking the square root of 56 fifteenths, okay, that is going to be the distance between f and g. Okay, and if I were to express this in any other reduced radical terms without the square root in the denominator and still maintain the exact form, the square root of 56 fifteenths will come out to the square root of 840 over 15, and that is reducible completely to 2 times the square root of 210 all over 15. Now, for the next set of items, say we have that f of x is equal to x and g of x is equal to e to the x. Now, to be able to work out the integration, we're going back to the integration by parts. Okay, so just as a forerunner, so you got the integral of u dv is equal to u times v minus the integral of v du. And we're going to be looking at f of x times g of x. So just setting things up for x times e to the x. Okay, notice, okay, with the integration by parts, we have u is equal to x and dv is equal to e to the x dx. Now, for u is equal to x, the differential statement becomes du is equal to dx. And for the antiderivative of e to the x dx, we're going to have e to the x. Again, so for u times v, we have x times e to the x. And minus the integral of v du, we have subtracting the integral of e to the x dx. So again, we have x e to the x minus e to the x, followed by the constant for this general integral. Now, working with the closed interval, with x going from negative to positive 1. So again, we have with f of x times g of x, again, we have x times e to the x, as x goes from negative to positive 1. Now, we already have the antiderivative already established. So we're looking at x e to the x minus e to the x as x goes from negative to positive 1. And substituting, so we have at the upper limit 1, okay, we have e to the first minus itself, so that will go out. And then subtracting, and what we have with the lower limit, we have negative 1 times e to the negative 1 minus e to the negative 1. Again, we have at 1, the expression is negligible, and deducting what we have from x equal to negative 1, we're going to have the subtraction of negative 2 times e to the negative 1. So the inner product of f with g is going to come out to 2 times e to the negative 1, or 2 all over e. Now, looking at the norm of f, okay, so we're looking at the square root of the inner product of f with itself. And again, so f, okay, again, is just x, and f of x times itself translates to x times x, which is x squared, and integrating x squared dx as x goes from negative to positive 1. We had the antiderivative at x cubed over 3, and as x goes from negative to positive 1, we're going to end up at 1/3, and what's going to be plus another 1/3, since 1/3 minus negative 1/3 is 1/3 plus 1/3, and so we have at 2/3. And for the norm of f, that is going to be the square root of 2/3, or the square root of 6 all over 3. And for what we have in the case of the norm of g, So we have the square root of the inner product of g with itself. And for the inner product of g with itself, so we have, as x goes from -1 to 1, we're looking at g of x times itself, where we have e to the x times e to the x is e to the 2x, and the antiderivative of e to the 2x will be 1/2 of e to the 2x as x goes from negative to positive 1. And for what we have at x equal to 1, we have 1/2 of e squared, and at x equal to -1, okay, we have 1/2 of e to the -2. And for the difference, okay, so you have 1/2 of e squared minus 1/2 of e to the -2. And just if you were to consolidate as a single statement, okay, we're going to have e to the 4th minus 1 all over 2e squared. And for the norm of g, so if I were to take the square root of the inner product of g, again, that could have been the square root of 1/2 e squared minus 1/2 of e to the -2. But just with the consolidated statement, okay, if I were to put this in reduced radical terms without the radical in the denominator, this would be the square root of 2e to the 4th minus 2 all over 2e. And for the distance between f and g, so that is going to be the norm of f minus g, and that is going to be the square root of the inner product of f minus g with itself. And so for the inner product of f minus g, going back to what we have in the closed interval as x goes from negative to positive 1, and we have this time with the product of the function f minus g of x with itself. And now for f minus g of x, okay, so that's going to be x minus e to the x. So you're looking at x minus e to the x times itself. And so in taking the product, so we have x squared minus 2x e to the x plus e to the 2x dx. And for the antiderivatives, okay, now we got x cubed over 3 plus what is going to be 1/2 of e to the 2x. And again, there's a bit of the integration by parts residue. So you got that minus 2 times the integral of x e to the x. So this part comes from the first and last terms, and then we have with minus 2 times the integral of x e to the x dx. And again, so we got with the first part here, so we got 1/3 plus 1/2 of e to the second, and you have minus from the lower limit, you got negative 1/3 plus 1/2 of e to the -2, and we have with this integral that we have here. So this is going back to what we had with the integration by parts. And again, that was from what we had earlier, x e to the x minus e to the x. Again, antiderivative of x e to the x dx is x e to the x minus e to the x. And this will be as x goes from negative to positive 1. So we have -2 times the quantity. So you got 1 e to the first minus e to the first, so that will go out. And then we have minus what is going to be the negative of e to the -1 minus e to the -1. And we have -2e to the -1. But subtracting a negative is going to change over to addition. And guess what? We're adding within, but we're multiplying by -2. So we now have 2/3 plus e squared over 2 minus what's going to be 1 over 2e squared. And we have minus 2 times 2e to the -1, or minus 4e to the -1. And ultimately consolidating as a solidified rational expression, okay, with the least common denominator at 6e squared. So we have 4e squared plus 3e to the 4th minus 3 minus 24e all over 6e squared. And so we have for the distance between f and g, okay, this is going to be the exact result here. And approximating this comes out to almost 1.68.